All right. So when we want to know whether you have something stored in your memory, there are different ways that we can evoke that kind of evidence that you have it stored in your memory. This first one is rapid relearning. On the left hand side of that panel, it says high school basic Spanish, and on the right hand side of that, it says college Spanish. A lot of times, people who have taken a foreign language in a world language in high school, when they go to take it again in college, they think, well, I don't really remember anything from high school, so I'll start at the first level. And then they rapidly relearn what they thought they had forgotten, right? It's actually in their memory banks. They maybe didn't have good cues for retrieving it previously, and so they thought, it's not in there anymore. I better start at the very beginning. That's what we call rapid relearning, when you can go from what you thought was not knowing it to demonstration of knowing it really quickly. Now, one way that rapid relearning works is through what's called semantic priming. Um, so, because you already know a particular word, it can spread to other related words, right? Let's say that I took Spanish through high school and college, but it's been a long time, minored in it in college. A long time since I've been actively using it, and so I've got very rudimentary grammar left anymore. But once you maybe think of a particular vocabulary word, it may spread to other related vocabulary words in your memory store and cause you to think, "Oh, I actually know those words too. I don't remember having, I didn't think I'd remembered this stuff." So being reminded by going back and taking that class again, and they take you very back to the beginning, and they go through the alphabet, and they go through the pronunciation, and they start with the present tense, and you're like, you know what? This is all starting to spread out, and I not only am remembering that I have the alphabet in the present tense, I'm actually remembering some vocabulary. I'm remembering even the past tense, maybe, which was the second thing you tend to learn. And it starts spreading. And so you actually get access to things that you thought were inaccessible. So it may be working through semantic priming. I'm not sure, but it might be one way that it works. So, once you have, this is a paired associates study where you have the first word of the pair as a cue, and the amount of time it takes for you to respond with the second word is a lot quicker than if you aren't provided with the first word initially. So in a paired associate scenario, we can show that those words actually serve as primes for each other. It's not the world's most dramatic speed up because we're talking about in milliseconds, that you're going like 100 milliseconds faster, 150 milliseconds faster. That's not very much, but it's noticeable, and it shows accessibility in the memory system. So rapid relearning is an important aspect, is an important way to test whether a person still has stuff in their memory or not. Another way to test what's in your memory is to give you recognition tests. So, multiple choice test would be an example of a recognition test. This one says, what is the capital of Uruguay? And you're supposed to recognize from the list of choices which one is the capital of Uruguay. So, presumably, this would happen in a class where you would have a reasonable expectation of knowing what that is, or you're from Uruguay. I would hope you'd know your capital if you're from Uruguay. So, recognition gives you the correct answer plus some distractors. And we want to see whether you can correctly recognize the answer among those distractors. So the correct answer is Montevideo, by the way, in case you don't know your Uruguayan capitals. So familiarity may explain some of the recognition process, right? So we look through the list, we say, well, this one feels familiar, so I must have seen it during my study time, so this must be the correct answer. I don't really know, but it feels familiar, so it must be the one I was studying. If something seems familiar, we tend to attribute it to an earlier encounter, like study time, or, well, this must be the person's name because I saw them a few days ago and this name feels familiar, so maybe this is their name, right? So it's, whoops, oops, I'm going the wrong direction. Arg. I like how I double down and keep doing it. So it could be that we're attributing it to having met them earlier or that we studied earlier. It could be actually that it just feels familiar and has nothing to do with earlier study time or earlier encounters, right? So familiarity, we rely on it, but it may not be accurate. It may not be the case that just because it seems like something we've seen before, that it must be relevant to the current context. So familiarity may help to explain why recognition is a good measure of memory, but it also can be one where intrusions can happen, where you mistakenly recall something that didn't really happen. Um, so, recognition, the act of recognizing something, and then source memory, which is your awareness of how you know something. Where did I get this? Is this what I studied or did I hear it on TV? Um, is this what I studied or is it something my mom said? Those kinds of things. Source memory is independent of recognition. They actually use different brain areas. So here we have on the left is your recognition capability. It's controlled by the rhinal cortex, which is illustrated there on the picture up at the top. Whereas um, recognizing where you got this information is controlled in the posterior hippocampus, right, which we've talked about so many different times. It clearly plays a role in memory, doesn't it? So if you got the source correct, if you correctly remembered where you got this information, you've got a particular area of the posterior hippocampus that's activating that's different from the source when you get the source incorrect. But those are independent parts of the brain and they're independent functions. So you may feel like something's familiar, you may feel like you're recognizing something, but you may actually be attributing it to the wrong source. Our textbook is very wise to talk a little bit about this familiarity effect and how often we hear something more than once and then start to think, yeah, that sounds familiar, it must be true. This is a thinking error that is really a profound thinking error, where we really honestly believe that if we hear it frequently, it must be true. And wrong things can be said many times, right? Just because multiple news outlets or multiple people on the internet or multiple TikTok videos or multiple sources are talking about the same thing doesn't mean that any of them are right. But because it sounds familiar and oh yeah, I've heard this before, we make a mistake and say it must be true. It's really super important for not only you to be aware of it so you don't fall victim to that error, but also spread the news. Just because you've heard it a lot doesn't make it true. It turns out that you can hear it multiple times from the same exact source and make the same familiarity error where you start to say, well, this must be true. I've heard it multiple times. Yeah, that same person has repeated it 10 times. That doesn't make it any more true than the first time they said it. So it's really super important to be aware that just because you've heard it a lot does not make it true. It's a really common thinking error. So we'll probably come back to related topics on that when we talk about thinking errors later. Another chapter for that. The last type of retrieval process I've got here is recall. I've got an example where it says essay topics, right? If you were to take an exam in a class where you're supposed to write what you know about something, that would be a recall test, right? In my research using paired associates, I show them the word pairs and then they are supposed to write from memory in any order as many of the words as they can remember. That's a free recall task. I don't give them any kind of cues about what was there. I just ask them to recall the information. So you're given some kind of broad cue. Write down as many of the words as you can recall in any order that identifies the information that's being sought. So in everyday life, somebody might be like, oh man, what was the name of that restaurant we went to? And the goal is for you to recall it, right? For you to be able to produce, a recollection of exactly which restaurant you went to. Of course, it's because your friend couldn't remember it either, but they're hoping that you can, right? It requires you to search your memory for like all the restaurants you've been. Maybe you can narrow it down to all the restaurants you've been to with that friend. That might help. But first, you have to search your memory, and then start letting that spreading activation draw you down, hopefully to the right place, right? So maybe you're thinking of all the places that you went with that friend, And that brings it down to some subset. And then you start thinking about details that might help you to decide which among these is the correct response. Um, you might have to ask for a little bit more detail, like which time, or what kind of restaurant was it? Was it a sit down or a fast food? Was it what kind of cuisine was it? Like, give me some hints. I don't know what you're asking for. The more detail the person can give you, the better chances that you'll pull up what they're actually looking for, right? Um, so yeah, this kind of recall task relies on your memory store being organized in such a fashion that you have a good chance of going down the right path and finding the information that you're looking for. Um, so, how do we go through the retrieval process? Well, the generation recognition model says that when we're trying to remember something, we generate possible responses. And we then have to pick out of all those possible responses the correct one. This is thought to be the kind of strategy that we all go through when we're doing a recall test. When we have to think of all the things we know, generate possible responses that are relevant, and then of the things that we think might be relevant, recognize the one thing that seems to be the appropriate response in this context, right? Thinking of, which restaurant do we go to? You can imagine that you might go through that process, right? Generate all the places I've ever gone to eat with this person and then narrow it down. Oh, the one that we went to last week? Okay, that's going to narrow it down. Oh, the one that served Asian food? Okay, I'm going to narrow it down. So that's the generation recognition model. The single process model says we generate possible responses. We don't think at all about whether any of them are correct or not. We instead just go with, the recognition of responses that seem familiar, right? And so in recognition and rapid relearning, we're going to see this strategy. So here we have the number of repetitions of the list on day one along the x-axis, and then the time in minutes taken to relearn the list on day two. And so what you see is that the more repetitions that the person had on day one, the shorter amount of time that they had to spend relearning the list on day two. This doesn't have any kind of correct responses or anything like that. They're just relearning, right? It's not a measurement of accuracy. It's a measurement of minutes to achieve some goal. So the person is demonstrating that they have the information stored in their memory by being quicker at producing it the second time, right? So one of the things that this is giving us a little insight into is that more repetitions when you're learning the material may produce more durable memory. But I want to make sure that you don't think that too hard, because repetition alone is not what it takes to get information into your long-term memory. We already talked a little bit about deep processes and stuff like that. So don't get confused and think, "Ooh, I'll just repeat information 10 times and it'll get into my memory." Well, not necessarily. So it's better if you can do one repetition and deeply process it than to do 10 very shallow repetitions. So that's my little sidebar on that. If you think back to that self-reference task that was in the last chapter where we talked about like those items that, those adjectives that related to a person's sense of self tend to be better remembered, you can kind of imagine that um, if that item is self-descriptive, it's probably something that the person's thought about a lot. They've probably deeply processed it, because it's something that they consider to be self-descriptive. And so they're like, yeah, I know that I act like that, and I've seen myself do it in a lot of different contexts. So there's a lot of repetition of it. They've probably deeply processed it and become aware of themselves being like that. And so when we think about the self-reference effect and how we remember best those things that relate to ourselves, it kind of makes sense as far as, the kinds of neural networks and details that we store in our memories. The self is probably a really good, powerful neural network. All right, I'm going to tell you a little story about Jack Hamilton, who was a pitcher, and he beaned, which means pitched a ball and hit Tony Canigliaro. He nearly blinded him. So here's Jack Hamilton's car. He was a pitcher for the Angels. 30 years later, he was interviewed about the time that he nearly blinded Tony Canigliaro. And he says he thinks about it every time a guy gets hit on TV. He said that it occurred during the sixth inning when the score was 2-1, that Canigliaro was the eighth batter. It was a day game, and that after that incident, he agonized over whether to return to Fenway with the Angels on the next road trip that season. So, this is his recollection of a very dramatic experience in his life. Here's Tony Canigliaro after he got beaned. Some of the inaccuracies. Okay, so we're not going to challenge whether he thinks about it every time a guy gets hit on TV. Okay, we'll start with the next claim. He said it was the sixth inning, it was the fourth. He said the score was 2-1, the score was 0-0. He said it was the eighth batter, it was the sixth batter. He said it was a day game, it was a night game. He says he agonized about whether to return to Fenway. It was the Angels' final road trip of the season. Maybe the next, I mean, it's been 30 years, so maybe the next time it was time to go to Fenway, he agonized over it. But long story short, of all the details, he didn't get any of those right. You would think day game versus night game would be meaningful. I'll give you the sixth inning versus fourth inning, and I'll give you the eighth batter versus sixth batter. Those are tiny details that don't really matter for the big scheme of things. The score being 2-1 versus 0-0, baseball is not the highest scoring sport in the world. So 2-1 kind of seems meaningfully different from 0-0. That kind of seems meaningful. It's surprising what he encoded and what kind of spreading activation probably occurred that caused him to start pulling in extra details. And I just wanted to illustrate that even if everything goes right, even if it's a super meaningful event, even if you've thought about it many times, there's a really high probability that details will be faulty in any of our memories. Our memories are not perfect. Our memories are not like a video recording of things that happened. We are completely dependent on the memory being reconstructed every time we think about it. And so there's opportunities, and this was 30 years later when he recalled these details. There are many opportunities every time he thinks about this event to accidentally store new information as if it were original information. And so I just really wanted to emphasize, even when we've got all the motivation in the world to remember the details, we may get them wrong. All right, let's go ahead and stop here and we'll come back and talk about implicit versus explicit memory.